there. Okay, today we're going to talk about ratios. And so a ratio is simply this mathematical thing that shows the relationship between two different numbers. It's a way of like comparing quantities or amounts with each other. And there's two different kinds of ratios that we'll be talking about. One is where we compare unlike quantities, and one is where we compare like quantities. So I think that the unlike quantities one is probably the easiest, and so we're going to start with one of those. Just as an example, okay? So here we have a classroom, okay? And these are all tables, and we've got these smiling, happy students at each table, and there are 6 tables, as you can see here. 1, 2, 3, 4, 5, and 6. And there are 4 people at each table, so there's 24 total students. And if I wanted to write a ratio of the number of tables in this classroom to students, I would do that. So let me write out my facts here first. So I have 6 tables, and I have 24 students. If I wanted to write a ratio that compared the tables to the number of students, this is how I would do it. I would put in this little, it's a colon, right? It's a ratio symbol in math. It's the sign of a ratio, but it's in writing, it's a colon, right? They're one and the same. So I would simply say this. So the ratios of tables in my classroom to students is 6 to 24. And that's how I would say it too, 6 to 24. And if I wanted to kind of, throw something else in there, I could write it like this. Most likely this is the way that you're going to write it, but it still portrays a ratio if I wrote it this way. Or I could also write it like that. Now, have you seen something like that before? Hopefully you have. This should look like a fraction to you. And it's just simply read the same way. So 6 to 24, even though it's written like a fraction. And it can get treated like a fraction too. If you look at this, if I was looking at this as a fraction, I could say, oh my gosh, this needs to be reduced, right? I can divide a 6 out of both of these, and I would end up with 1/4, right? You can do that with a ratio also. So if I come back up here, I could look at this guy and say, oh, 6 to 24. Let me grab my eraser here. 6 to 24. I could divide 6 out of both of those. I could also write that as the ratio of 1 to 4. And you can kind of see that in our picture here too. How many students are sitting at one table? Well, there's 1, 2, 3, 4 happy smiling little faces, right? And so that would be this, the reduced version of that ratio. So there's 6 total tables in the classroom, there's 24 students, and I could reduce that and say at every one table, 4 students are sitting. Let's look at another example of a ratio with unlike things. Say I have a recipe that has eggs and lemons in it, okay? And the recipe says that for every 4 eggs, I add 2 lemons, okay? 4 eggs to every 2 lemons. That's what my recipe says. And if you see right there, I basically have my ratio already written. Or I could say like this, right? I could write it as a fraction. That's totally acceptable as well. Can I reduce this ratio? I sure can. So that what it basically means is that for every 2 eggs, I put in 1 lemon, right? If I wanted to reduce the recipe, make a smaller batch or something like that, I could do this. Or if I, just wanted to clarify for myself, I would do this. If this was a fraction, right, we would just say that this was 2. But because it's a ratio, we want to leave this 0 on, or not the 0, it's a 1. We want to leave this 1 on the bottom. Because if we get rid of it, like we would in dealing with a fraction, we would lose the fact that the 2 is in relation to the 1. And we don't want to lose that. Let's look at another example here. Say I went to the store and I bought 15 donuts. How do you spell donuts? Donuts, okay? And I'm going to bring them back and share them with my classroom, and I have 20 students in class. So if I was going to write a ratio of the donuts to students, it would be 15 to 20, right? And again, is this one that I can reduce down? Hopefully you're starting to see that just like fractions, they kind of stick out at you. I can divide 5 out of both of these, right? 15 divided by 5 is 3. 20 divided by 5 is 4. So I could say that this is like my final ratio. For every 3 donuts, let me start again. There's 3 donuts for every 4 students. 3 donuts for every 4 students. So these are unlike ratios, where you're comparing 2 different things, donuts and students, eggs and lemons. In the other example, we were comparing tables to students. What happens, though, if I want to compare something that's like? Say I want to compare types of money to each other. Then it gets a little bit trickier because we kind of have to change it into common terms, okay? So say that I want to compare, let me write this out for you. I want to compare 1 dime to $1, okay? So 10 cents, right, to $1. If I were just to write my ratio, so if I have this, I have 1 dime to $1, can I do that? 1 to 1? What this would mean is that they are exactly equal. And I hope that you know that 10 cents is not equal to $1. And let me put these out here so that we can kind of look at them, right? There's a dime and there's $1. Are these 2 things equal? Hopefully you're seeing that they're not equal and that this ratio right here is actually incorrect. Okay? So I have to write a ratio, right? So what am I going to say instead? Well, I'm going to have to put everything into what we call common terms. So if I was going to change this dollar into a stack of dimes, how many dimes would I change it into? Well, there are, let me move them over here. 10 dimes in $1, right? So if I have 1 dime and I'm comparing it now to 10 dimes, that would make my ratio 1 to 10, right? And this is the correct answer. If I wanted to write a ratio to represent 1 dime to $1, I have to forget about the dollar in this form, right? And think about it as a set of 10 dimes. And so then I would write my ratio as 1 dime to 10 dimes because I know that the 10 is equivalent to the dollar. Let's look at another example of this. Let me move my change off the board here. Let's look at another example. And this example involves measurement, okay? Say I want to compare 3 inches, oh, let me get it on the screen there, to 3 feet, right? So, again, at this point, it looks like, oh, I should be able to write 3 to 3, right? There's my ratio. But it's not that way because, again, this says that these 2 things are equal. let me give you some visuals for this, okay? These are little 1-inch cubes, or 1-inch tiles, okay? They're 1 inch along this side. So if I put them together, this is 3 inches long, okay? Let's look at how big 3 feet are. Well, if you remember, 1 foot is 12 inches. So here I have a ruler, 12-inch long ruler. That's 1 foot. Here's a 2nd foot. Here's a 3rd foot, right? If I were to put these end to end, it would be really long. It would be off of my movie screen. You wouldn't be able to see it. Are these two things equal? 3 inches to 3 feet? Hopefully you're seeing that just like with the money, this ratio is not correct. And so in order to deal with these 3 feet and compare it accurately to the 3 inches, I have to write these 3 feet right here in their inches form. Okay? So if I was going to write 3 feet in inches, well, I know there's 12 inches in each foot. That equals 1 foot, right? So I'm going to do 12 times 3, which will tell me 36 inches. So if I was going to write my new ratio, it would be 3 to 36. So I've converted this guy to be in inches. They have the same common term of inches now. I can compare them accurately, and my ratio is 3 to 36. Anything you notice about that? Hopefully you're saying, but wait a minute, we can reduce that. And you were totally right. I can divide a 3 out of both of these, right? So if I divide a 3 out of both of them, I end up with a new ratio of 1 to 12. And you can kind of see that too with our visualization also. I had 3 rulers and I had 3 of these. So I could, kind of pair them off if I wanted to and say, here's my 1 inch to 12 inches, right? 1 inch to 12 inches. And I've written an accurate like ratio. So hopefully this helps. We'll talk a little bit more about ratios and proportions in the next video.